All right, guys, this is your pre-lab for your next lab, the Wax Paper Watersheds Lab. It's going to be number 44 in your notebook, and you're going to write Wax Paper Watershed. Wax Paper Watershed. So we're going to start by clarifying a couple of terms here that you're going to need to understand in order to do this lab. And the first is the word watershed. What exactly is a watershed? Watershed is the area of land that drains into one body of water. So for example, if this is a river that runs through a certain area, and maybe at the end it opens up into a bay, a cove, a lake, something like that. Around this body of water, there is an area of land where any rainfall that falls on this land will flow downhill and eventually get to that river. Okay, all around here, water that lands will flow towards that river. Water that flows out here, for example, or lands out here, would flow toward a different river or stream. But water that lands inside that dashed line is going to flow toward that river. And that's important because any chemicals, pollution, any human industry that's happening inside that dashed area is all going to have an effect on this river. And it could have an effect on people downstream as well. Now, a river basin is just a big watershed. And it's usually made up of lots of smaller watersheds. So here's today's lab. The question we're trying to answer is, what shape does a watershed usually have? And when I say what shape, I mean what shape when you look down at it from the sky, but also what shape when you look at it from the edge. So for example, if this is our river and we're looking at it from the side, and the watershed ends here and here, what shape will it have in between? Where will the highest places be and where will the lowest places be? So, next step, as always, is to come up with your hypothesis. And that, of course, is going to be your guess. Now, on the last lab report, some of you made the mistake of writing a very short hypothesis, which is okay in your notebook. But when you write your lab report, you have to have a complete sentence here. So this needs to be a complete sentence on your lab report. Okay? Now, as always, we're going to have our methods and materials next. I recommend a box where you write in all of the materials and then a place to list all of your steps as you do them. And that's going to bring us to your data table, okay? Now, for this particular lab, the data is going to be two different things. On one hand, you're going to have a photo of your watershed. The other thing you're going to have is a drawing of your watershed, top down and side view. Top down and side view. The analysis, there will not be any analysis for this lab. No graph that you have to make or anything like that. And your conclusions. First was your hypothesis correct? Secondly, what problems or mistakes did you make? Third, why are watersheds important to understand? And lastly, what are ideas that you have for future experiments? Okay? Now, we'll do the lab in class tomorrow, and your lab report will be due 1 week later. You'll get tons of reminders from me, but you now have all the information you need to do that, and you will receive a Google Classroom assignment to do your lab report on the same day as the lab. Now, continue watching to see a preview of what the lab looks like. All right, guys, this lab is super easy. In fact, you only have 2 supplies, 2 materials that you have to list in your lab report. One is a squirt bottle filled with water, just plain water, and another is a piece of wax paper. Wax paper, just like the ground, tends to repel water, so the water moves downhill, pulled by gravity. So step 1, super simple, you take your wax paper and you crumple it up. Now, you don't want to crumple it up too much, but you want to make sure that it's got a lot of different high points and low points, mountains, hills, valleys, that kind of thing. And then once you've done that, I want you to open it back up. But you don't want to make it flat, okay? You want to leave in here a variety of high areas and low areas, okay? Then you're going to place this wax paper in the bottom of the sink, okay? And then the third step, after you've crumpled it up, opened it up, put it in the bottom of the sink, is you're going to take your spray bottle and you're going to simulate rainfall so you can see the way the water moves. Now, to do that with these squirt bottles, they have an adjustable nozzle. And if you leave it unscrewed too far, you get too sharp a jet. And if you leave it tightened too far, you get too much of a mist. So here's what I recommend. If you turn the nozzle all the way down, tight as it can go, and then untwist it 1/2 turn, you get a really good level of mist that can simulate rain. Then all you have to do is squeeze the trigger a few times to get the water going. Yeah, unscrew it about 2 turns from fully closed, and then you just squeeze close enough to the sink that it doesn't make a lot of spray, and keep doing that gently, watching what happens, and remembering that you have to capture at least 1 good photo for your lab report, as well as a drawing of what it looks like from the top down and also from the side view. Now, as you add water, you'll see it begin to pool and flow downhill, forming lakes and rivers and streams. When you add a whole lot of water, eventually the whole thing will get weighed down and flattened, and that's when you stop. And when you're done, you simply leave the spray bottle on the counter, and you take your wax paper, wring out all the excess water, and throw that away. And that's it. All done.